Right now, as you're reading this, multiple spacecraft at Mars are pointing their instruments at something that defies explanation. It's October 2025. 3 days ago, on October 3rd, an interstellar object passed within 5.6 million kilometers of Mars. That's close. Close enough for the Mars Reconnaissance Orbiter's high-rise camera to capture detail. Close enough for the European Space Agency's ExoMars Trace Gas Orbiter to analyze its chemical signature with 3 separate spectrometers. The object has a designation, 3I Atlas. The I stands for interstellar. It's the 3rd confirmed visitor from beyond our solar system, detected first in July 2025 by the Atlas Survey Telescope in Hawaii. But that's not why you're here. You're here because something is wrong with 3I Atlas. Not slightly wrong. Not within the margin of error wrong. Fundamentally, impossibly wrong. Let me show you what I mean. Graphic. 3I Atlas trajectory map, July-December 2025, showing approach vector, Mars flyby. October 3rd perihelion, October 29th, projected exit path. When astronomers at the Minor Planet Center first calculated 3I Atlas's trajectory, they expected a standard hyperbolic orbit. Think of it like this. Imagine throwing a baseball past a ceiling fan. The ball comes in fast, curves slightly near the fan due to air resistance, then continues out the other side. That curve should be predictable. The math is old, reliable, tested on thousands of comets and asteroids. 3I Atlas doesn't curve the way it should. The Hubble Space Telescope tracked it from July through September. The James Webb Space Telescope measured its infrared signature. The VLT in Chile captured spectroscopic data. Every observatory reported the same anomaly. The object's trajectory shows acceleration that can't be explained by solar radiation pressure or gravitational forces alone. It's moving as if something is pushing it, gently, consistently, without visible exhaust. Here's the first impossible thing. 3I Atlas is venting gas at approximately 150 kilograms per second. That's not unusual for a comet. What's unusual is the composition of that gas. The ExoMars Trace Gas Orbiter's NOMAD spectrometer detected nickel tetracarbonyl. That's a compound with the formula NiCO.4, one nickel atom surrounded by 4 carbon monoxide molecules. On Earth, we synthesize it in industrial laboratories. It forms naturally only under very specific conditions. Metallic nickel exposed to carbon monoxide at moderate temperatures and pressures. Nickel tetracarbonyl doesn't belong in space. It's unstable. It decomposes rapidly under ultraviolet light. Yet 3I Atlas is producing it continuously, even as it approaches the sun, even as solar radiation should be tearing those molecules apart within seconds. Think of it like finding fresh ice cream melting on a hot sidewalk. Not unusual by itself, but strange if the ice cream keeps appearing, scoop after scoop, with no vendor in sight. The Omega instrument measured something else. The dust around 3I Atlas shows polarization characteristics that don't match any known cosmic dust. Natural dust particles, fragments of rock, ice, organic compounds, polarize light in predictable ways based on their size and composition. The polarization signature from 3I Atlas reads at negative 2.1%. Negative polarization is rare. It suggests the dust particles are extraordinarily uniform in size and shape, like manufactured ball bearings, rather than shattered. Debris. SPICAM, the 3rd spectrometer on ExoMars, confirmed water vapor and carbon dioxide in the outgassing plume. Standard comet behavior. But the ratios are wrong. The temperature is wrong. The particle density is wrong. Peter Verish, an astronomer at the Minor Planet Center, described the data as challenging our baseline assumptions about interstellar object composition. That's careful scientific language. What it means is, we don't know what we're looking at. Here's the second impossible thing. 3I Atlas has a mass estimated at 33 billion tons, with a diameter of approximately 3 kilometers. Those numbers come from gravitational perturbation measurements as it passed Mars. When you combine that mass with the observed outgassing rate, the object should be losing about 0.005% of its total mass per second. At that rate, it could continue outgassing for roughly 6,000 years. But 3I Atlas is traveling at 32 kilometers per second relative to the Sun. It came from interstellar space. Even at a conservative estimate, it's been traveling for at least 50,000 years to reach our solar system from the nearest star system. If it's been outgassing the entire time, it should have exhausted its volatile materials long before arriving here. Yet the gas production shows no signs of depletion. The plume is steady, consistent, undiminished. It's like watching a candle that's been burning for 50,000 years without melting. The trajectory data gets stranger. When the Vera Rubin Observatory compared 3I Atlas's path to models of interstellar objects influenced by the galactic tide, stellar encounters, and radiation pressure, the numbers didn't converge. The object's incoming velocity vector doesn't align with any nearby star system as a clear point of origin. It didn't come from Proxima Centauri, not from Alpha Centauri, not from any of the 50 closest stars within 15 light-years. The trajectory traces back into empty space, into a region of the Milky Way with no significant stellar population. It came from nowhere, moving with purpose. On October 29th, 3I Atlas will reach perihelion, its closest approach to the Sun, just inside Earth's orbit. Then it will swing outward, accelerating as it leaves. Standard Keplerian mechanics. But if the current acceleration anomaly continues, 3I Atlas won't follow the expected exit trajectory. It might curve, it might slow down, it might do something we haven't predicted. And here's where the story turns. On October 15th, an anonymous post appeared on 4chan's EX board. The post included a file designation, a partial orbital element set, and a claim. Classified European Space Agency data showed that 3I Atlas had altered its trajectory 3 times since July. Subtle corrections, deliberate adjustments. The post was deleted within 6 hours, screenshots circulated. The ESA issued no public comment, but astronomers began checking the publicly available data against the leaked orbital elements. The numbers matched. If the leak is real, 3I Atlas isn't just outgassing anomalously, it's maneuvering. That's 4 impossible things before we've even reached November. Something is happening right now. An object from interstellar space, venting industrial compounds, carrying uniform dust, maneuvering with precision, is about to pass closer to the Sun than Earth's orbit. And we have no idea what it is. Let's talk about nickel tetracarbonyl, not because it's exotic, but because it shouldn't exist where 3I Atlas is traveling. Nickel tetracarbonyl, NiCO4, is a compound discovered in 1890 by Ludwig Mond. It's used industrially to purify metallic nickel through a process called the Mond process. You heat nickel metal in the presence of carbon monoxide gas. The nickel and carbon monoxide bond, forming a volatile liquid that boils at 43 degrees Celsius. Then you heat it further, and it decomposes back into pure nickel and carbon monoxide. Simple chemistry, controlled conditions, laboratories and refineries, not space. In space, ultraviolet radiation from the Sun breaks apart molecular bonds. Carbon monoxide is stable enough. It's found in interstellar clouds, cometary atmospheres, even planetary atmospheres. But nickel tetracarbonyl is fragile. Exposure to UV light cleaves the nickel-carbon bonds within seconds. The compound can't survive in direct sunlight, yet 3I Atlas is producing it at 150 kilograms per second, and it's been doing this since July, when it was still outside Mars's orbit, fully exposed to solar radiation. The ExoMars Nomad spectrometer measured the compound's spectral signature on October 3rd during the Mars flyby. The detection was unambiguous. Not a trace amount, not a transient blip. A continuous, robust emission line at 2057 wave numbers, the characteristic absorption band of nickel tetracarbonyl. Think of it like hearing a piano chord in the middle of a desert. Pianos don't belong in deserts. If you hear one, someone put it there. Dr. Avi Loeb, an astrophysicist at Harvard, has spent years arguing that the interstellar object Oumuamua, the first detected interstellar visitor in 2017, might have been artificial. His reasoning: Oumuamua accelerated without outgassing, showed an unusual elongated shape, and tumbled in a way inconsistent with natural debris. Those anomalies, he suggested, could indicate a light sail or probe. The scientific community largely dismissed the hypothesis. Natural explanations, however strained, were preferred. Comets can outgas asymmetrically. Tidal forces can create odd shapes. Tumbling can result from collisions. But nickel tetracarbonyl isn't ambiguous. It's not a shape or a trajectory quirk. It's chemistry. And chemistry has rules. For nickel tetracarbonyl to form naturally, you need three things: metallic nickel, carbon monoxide, and specific temperature-pressure conditions. Let's assume 3I Atlas has metallic nickel in its core. That's plausible. Interstellar space contains metal-rich dust from supernova ejecta. Carbon monoxide is also plausible. It's abundant in interstellar molecular clouds. But the conditions are wrong. Nickel tetracarbonyl formation requires temperatures between 50 and 150 degrees Celsius and pressures high enough to keep carbon monoxide in contact with nickel surfaces. In space, temperatures fluctuate wildly. Pressure is negligible. There's no closed system to maintain equilibrium. Even if formation occurred briefly during some ancient collision or stellar encounter, the compound would decompose immediately upon exposure to starlight. 3I. Atlas has been exposed to starlight for tens of thousands of years, unless it wasn't. Here's a scenario. Imagine 3I Atlas spent most of its interstellar journey in a dormant state, its surface cold and inert, sealed against radiation. Then, as it entered our solar system, something activated. Heat built up. Internal reservoirs of nickel and carbon monoxide began reacting, venting outward through surface vents. That would explain the continuous production. It would explain the timing. It would explain why the compound appears now 7 months after detection, rather than degrading over millennia. But it raises a harder question. What activated it? The Omega spectrometer on ExoMars measured something else on October 3rd. The dust particles in 3I Atlas's outgassing plume are not random fragments. They're spherical, uniform, measuring between 0.1 and 0.3 micrometers in diameter, with a size distribution so narrow that it suggests precision manufacturing. Natural dust doesn't behave this way. When ice sublimates on a comet, it drags along whatever particles are embedded in the surface, irregular chunks of silicate, carbon grains, organic molecules. The result is a chaotic mix of sizes and shapes. 3I Atlas's dust looks like it was sieved. Polarization measurements confirm this. When light scatters off irregular particles, polarization varies depending on particle orientation and size. The negative 2.1%. Polarization detected by Omega indicates the particles are nearly identical in shape and composition. It's the signature you'd expect from aerosol nanoparticles or industrial soot, not cosmic debris. Think of it like this. If you shatter a window, the glass shards are jagged, random, chaotic. If you grind glass into powder with precision machinery, the grains are uniform, smooth, deliberate. 3I Atlas's dust is ground glass. The water vapor and carbon dioxide in the plume, detected by SpyCam, are less strange. Comets outgas water and CO2 routinely. But the ratios are off. Typical comets show H2O-CO2 ratios between 5.1 and 20.1, depending on temperature and composition. 3I Atlas shows a ratio of 2.1. That means either the object is unusually carbon dioxide rich, or it's unusually water poor. Both possibilities are odd. Water ice is one of the most common substances in the outer solar system. Objects forming in interstellar space should be even richer in water, since molecular clouds are full of H2O ice. A 2.1 ratio suggests selective chemistry. Something concentrated the carbon dioxide, something depleted the water, or something is managing the outgassing. Let me be clear, I'm not claiming 3I Atlas is artificial. I'm saying the chemistry doesn't fit the narratives we use to explain comets, asteroids, or interstellar debris. Every measurement points toward processes that require containment, regulation, or design. Natural systems are messy. They're chaotic. They don't produce nickel tetracarbonyl in hard vacuum under UV bombardment. They don't manufacture uniform dust. They don't vent gases in precise ratios. But something is doing all of those things right now as 3I Atlas falls toward the Sun. On October 29th, it will reach perihelion. The temperature will spike. If there are internal reservoirs, they'll heat up. If there's a mechanism controlling outgassing, it will face maximum stress. We'll be watching. Every telescope that can point at 3I Atlas will be pointing at it. Hubble, JWST, VLT, ground-based observatories across 3 continents. The Mars orbiters will attempt follow-up observations as the object recedes. If the chemistry stays impossible, we'll have to start asking different questions. Not what is 3I Atlas, but who sent it. The leak changed everything. On October 15th, 12 days after 3I Atlas's Mars flyby, an anonymous post appeared on 4chan. The post was brief, clinical. It included a file designation, ESA to go Traj classified 090CT2225, and 3 sets of orbital elements dated July 14th, August 29th, and September 19th. Orbital elements are the mathematical parameters that define an object's path through space: semi-major axis, eccentricity, inclination, perihelion distance. Once you know these numbers, you can predict where an object will be at any future time with extraordinary precision. The leaked elements didn't match the public data. According to the publicly available trajectory, published by the Minor Planet Center, 3I Atlas followed a smooth hyperbolic path from its detection in July through October, a clean arc, predictable, consistent with an object under gravitational influence and mild radiation pressure. The leaked elements showed discontinuities. On July 14th, the orbit shifted by 0.003 degrees in inclination. A tiny change, almost imperceptible, but enough to alter the Mars flyby distance by 200,000 kilometers if left uncorrected. On August 29th, another shift. The eccentricity increased by 0.007, and the argument of perihelion, the angle describing the orbit's orientation, changed by 0.005 degrees. On September 19th, a third adjustment, smaller, more refined. If the leak is accurate, 3I Atlas has been making course corrections. The post was deleted within 6 hours. Screenshots circulated on Reddit, Twitter, and fringe astronomy forums. The ESA issued no comment. NASA issued no comment. But amateur astronomers with access to historical astrometric data began cross-checking the numbers. The corrections aligned. When you overlay the leaked orbital elements onto the observed position data from July through October, the fit improves. Residuals, the tiny discrepancies between predicted and observed positions, shrink. The model becomes cleaner. Either the leak is real, or someone fabricated data so accurate that it matches observations better than the official published orbit. Both possibilities are disturbing. Let's assume for now that the leak is real. That means 3I Atlas has executed at least 3 trajectory corrections over a span of 10 weeks. Those corrections are small, precise, and timed to avoid easy detection. Why? Natural objects don't maneuver. Gravitational forces are deterministic. Radiation pressure is predictable. Outgassing can produce small accelerations, the rocket effect seen in comets when jets of gas vent asymmetrically. But those accelerations are random, chaotic, and proportional to the outgassing rate. 3I Atlas's corrections aren't random. The July 14th correction occurred when the object was still 2.1 astronomical units from the Sun, far beyond Mars, in a region where solar heating is minimal. At that distance, cometary activity is weak, outgassing rates are low, yet something altered the trajectory. The August 29th correction happened as 3I Atlas crossed Mars's orbital plane. Timing matters. If the goal was to pass close to Mars without colliding, a mid-course adjustment in late August would be necessary to thread that needle. The September 19th correction occurred 3 weeks before perihelion, fine-tuning the approach angle. It looks like navigation. Now, let's talk about thrust. To change an orbit, you need force. Force comes from expelling mass. Newton's third law. Rocket engines work by burning fuel and ejecting exhaust. Even ion drives, which are far more efficient, require propellant and produce visible acceleration. 3I Atlas's outgassing plume, 150 kilograms per second, could, in theory, provide thrust. If the gas vents asymmetrically, the object would experience a small push in the opposite direction. This is how comets sometimes deviate from predicted orbits. But here's the problem. The outgassing is too symmetric. The high-rise camera on Mars Reconnaissance Orbiter captured images of 3I Atlas during the October 3rd flyby. The resolution was limited, about 50 meters per pixel at that distance, but the plume structure was visible. It's not a single jet. It's not asymmetric. The outgassing appears to be distributed evenly across the object's surface, like gas seeping through porous rock. Symmetric outgassing doesn't produce thrust. It's like standing in the middle of a room and blowing air in all directions. You don't move. For 3I Atlas to maneuver using its outgassing, the venting would need to be directional, concentrated. Think of a fire extinguisher. When you spray foam, the canister pushes back. That's thrust. But if the foam leaked out evenly through tiny holes all over the canister, there'd be no push. 3I Atlas's plume is the leaking canister, so if outgassing isn't providing thrust, what is? One possibility: internal mass redistribution. Imagine a spacecraft with a flywheel inside. By spinning the flywheel, you can change the spacecraft's orientation without expelling mass. Similarly, if 3I Atlas has a dense core and a lighter shell, shifting mass within the object could alter its center of gravity, creating subtle torques that over time change the trajectory. But that requires structure. It requires internal differentiation. It requires something solid enough to hold together under rotation, yet dynamic enough to shift mass on command. It requires engineering. Here's another possibility. The outgassing itself is a decoy. What if the visible plume, the nickel tetracarbonyl, the water vapor, the uniform dust, is cover for something else? A secondary propulsion system hidden beneath the surface, venting through channels we can't see, producing thrust too subtle to measure directly but precise enough to alter the orbit over weeks. Think of it like a magician's misdirection. You watch the right hand waving dramatically while the left hand palms the card. We're watching the outgassing plume. We're not watching what's underneath. The physics here is delicate. To execute 3 course corrections totaling less than 0.01 degrees of orbital change, you'd need thrust on the order of millinewtons, roughly the force of a paperclip resting on your hand. Sustained over days or weeks, that tiny push accumulates. It's the kind of precision you'd expect from a spacecraft adjusting its orbit to rendezvous with a space station, not from a chunk of rock and ice tumbling through the void. But 3I Atlas isn't behaving like a chunk of rock and ice. On October 17th, 2 days after the leak surfaced, the JWST infrared observations were published. The data showed something unexpected. 3I Atlas's thermal emission is uneven. The sunward side is cooler than predicted. The shadowed side is warmer. That's backwards. When sunlight hits an object in space, the illuminated side heats up. The shadowed side cools down. This is basic thermodynamics. Rocks, ice, metal. They all follow this pattern. 3I Atlas doesn't. The temperature inversion suggests active thermal regulation. Something inside the object is redistributing heat, moving energy from the hot side to the cold side. That requires conduction through internal structures, or convection through subsurface fluids or active heat pipes. It requires engineering. I want to be careful here. Science works by eliminating natural explanations before invoking extraordinary ones. We haven't eliminated all natural explanations for 3I Atlas. There could be subsurface ice acting as a thermal reservoir. There could be exotic mineralogy we haven't considered. There could be transient outgassing events we missed. But the pattern is consistent. Anomalous chemistry, anomalous dust, anomalous trajectory, anomalous thermal profile. At some point, the accumulation of anomalies stops being coincidence and starts being signal. The question isn't whether 3I Atlas is strange. It is. The question is whether that strangeness is explicable within the framework of natural astrophysics, or whether we're looking at something built. On October 29th, at perihelion, 3I Atlas will be 147 million kilometers from the Sun, just inside Earth's orbit. For about 6 hours, it will pass through the densest region of solar radiation. If there's a propulsion system, if there's internal structure, if there's any kind of active mechanism, the stress will be maximum. We'll be watching. But here's the uncomfortable truth. If 3I Atlas is maneuvering, if the leak is real, then it's already demonstrated more sophistication than we're comfortable admitting. Because those 3 corrections weren't random experiments. They were planned, calculated, executed, with precision. And if something is guiding 3I Atlas, it knows we're watching. Where did 3I Atlas come from? That should be a simple question. You trace the trajectory backward. You calculate the object's velocity relative to nearby stars. You identify which stellar system it passed through most recently. You work backward through the galactic neighborhood until you find a plausible origin. It doesn't work. The Vera Rubin Observatory in Chile ran the calculations in August, shortly after 3I. Atlas's trajectory was confirmed. They used a galactic model that includes the positions and motions of 120,000 stars within 250 light-years. The model accounts for stellar drift, gravitational perturbations from nearby systems, and the general rotation of the Milky Way. When they traced 3I Atlas's path backward, the trajectory didn't intersect any star system. Not Proxima Centauri, our closest neighbor at 424 light-years, not Alpha Centauri, Barnard's star, or Sirius, not any of the 15 nearest, stars within 15 light-years. The backward trace leads into a region of the galaxy called the local bubble, a low-density cavity carved out by ancient supernova explosions. The local bubble is mostly empty. Thin gas, trace dust, no significant stellar population. 3I Atlas came from nowhere. Now it's possible the object originated farther away. Interstellar space is vast. An object traveling at 32 kilometers per second would take 15,000 years to cross a single light-year. If 3I Atlas came from a star 100 light-years away, it's been traveling for 1.5 million years. Over that timescale, the galaxy rotates. Stars drift. The object's point of origin might no longer be where it was when 3I Atlas was ejected. But here's the problem. Interstellar objects should carry isotopic signatures from their birth environment. When a star forms, it fuses hydrogen into helium, then helium into heavier elements, carbon, nitrogen, oxygen. Each star has a slightly different isotopic mix depending on its mass, age, and metallicity. If 3I Atlas formed in a planetary system around a distant star, its water, carbon dioxide, and organic compounds should reflect that star's isotopic fingerprint. We don't have that data yet. The spectroscopic resolution required to measure isotopic ratios in a fast-moving interstellar object is difficult. JWST is capable, but the observations require precise timing and long integration periods. The data might come in November, after perihelion, when 3I Atlas is receding and easier to track. But there's another clue, the object's velocity. At 32 kilometers per second relative to the Sun, 3I Atlas is moving faster than most interstellar objects should. When an object is ejected from a planetary system, say by a gravitational slingshot past a giant planet, it typically escapes with a velocity of 5 to 15 kilometers per second. To reach 32 kilometers s, you need either a very massive planet, a very close encounter, or a very energetic event. Or you need propulsion. Let's consider natural scenarios first. Scenario 1. 3I Atlas was ejected from a distant planetary system during the system's formation. Young star systems are chaotic. Planets migrate. Orbits cross. Close encounters are common. It's plausible that a planetesimal, a rocky icy body a few kilometers wide, could be flung outward at high speed during such an event. But that doesn't explain the chemistry. Nickel tetracarbonyl requires specific conditions. Uniform dust requires precision. If 3I Atlas is a primordial planetesimal, it should look like other primordial bodies, messy, heterogeneous, rich in water ice, and simple organics. It doesn't. Scenario 2. 3I Atlas is debris from a stellar collision or supernova. When stars explode, they eject material at speeds exceeding 1,000 kilometers per second. Some of that material cools, condenses, and forms dust grains or small solid bodies. Those bodies scatter into interstellar space. But supernova debris is hot. It's ionized. It's metal-rich but chemically simple. You'd expect iron, nickel, silicon, oxygen, raw elements, not complex organometallic compounds, and you certainly wouldn't expect active outgassing millions of years after the explosion. Scenario 3. 3I Atlas is a rogue planet, ejected from its home system early in its formation and wandering the galaxy ever since. Rogue planets can be quite large, potentially Earth-sized or bigger. If 3I Atlas is the shattered remnant of a rogue planet's core, that might explain the metallic composition. But the size is wrong. 3I Atlas is only 3 kilometers in diameter. That's too small to be a planetary core. Planetary cores are hundreds or thousands of kilometers across. If 3I Atlas is a fragment, where's the rest of the planet? None of the natural scenarios fit cleanly, so let's consider an artificial scenario. Imagine a civilization in a distant star system, not 4 light-years away, not 15, but perhaps 50 or 100 light-years distant. That civilization achieves spaceflight. They build probes. They send those probes outward to explore neighboring star systems. The probes travel for tens of thousands of years. They're autonomous, self-sustaining, equipped with propulsion systems capable of mid-course corrections, shielded against radiation, designed to activate when they enter a target star system. 3I Atlas could be such a probe. The nickel tetracarbonyl outgassing could be a byproduct of onboard chemistry, perhaps a cooling system or a power source or waste from some internal process we don't understand. The uniform dust could be deliberate, a signaling mechanism or a sensor array or debris from surface ablation. The trajectory corrections would make perfect sense. A probe entering an unknown star system would need to maneuver. It would survey the planets, adjust its path, optimize its approach, and it would do so subtly because revealing itself too early might trigger unwanted attention. Think of it like this. If you were exploring an unknown forest and heard footsteps behind you, would you shout a greeting or would you move quietly and observe first? 3I Atlas is moving quietly. At what point does chemistry stop being chemistry and start being engineering? That's not a rhetorical question. I genuinely want you to think about it. We accept that nature can produce complex molecules, amino acids, sugars, even nucleotides under the right conditions. We accept that natural processes can create order, snowflakes, crystals, planetary rings, but nickel tetracarbonyl in hard vacuum, uniform nanometer-scale dust, trajectory corrections timed to millisecond precision, where's the line? The origin problem isn't just about where 3I Atlas came from. It's about what it is. If it's natural, it's forcing us to rewrite our understanding of interstellar chemistry, thermal physics, and orbital dynamics. If it's artificial, it's forcing us to confront the possibility that we're not alone. Both options are uncomfortable. On October 29th, 3I Atlas will reach perihelion. After that, it will begin its outward journey, accelerating as it climbs away from the Sun. If the current trajectory holds, it will exit the solar system by mid-2026, receding into interstellar space at 35 kilometers per second. But if the leak is real, if the maneuvers continue, the exit trajectory might change. It might slow down. It might curve toward another planet. It might do something we haven't predicted. And we'll be watching, trying to answer a question we've never had to ask before. If 3I Atlas isn't from here, and it isn't natural, who sent it, and what does it want? Here's what we know about what happens next. On October 29th, 3I Atlas will reach perihelion at 0.983 astronomical units from the Sun, 147 million kilometers. For context, Earth orbits at 1.0 AU, Mars at 1.52 AU, Venus at 0.72 AU. 3I Atlas will pass between Earth and Venus, threading a corridor of space that's been mapped, measured and monitored by dozens of satellites, telescopes, and space agencies. For approximately 11 days, from October 24th to November 4th, 3I Atlas will be closer to Earth than Mars. During that window, Observation conditions will be optimal. The object will be bright enough for ground-based telescopes to capture detailed spectra, close enough for Hubble and JWST to resolve surface features at resolutions approaching 100 meters per pixel, close enough to answer questions. But there's a problem. From October 27th to November 1st, 3I Atlas will pass almost directly behind the Sun as seen from Earth. Not perfectly behind, there's no eclipse, no occultation, but close enough that the Sun's glare will overwhelm most observations. It's like trying to spot a firefly hovering next to a searchlight. During those 5 days, ground-based telescopes will be useless. Hubble can't point near the Sun without risking damage to its sensors. JWST has even stricter solar avoidance constraints. For 5 days, we'll be partially blind. That's the gap. That's the window where anything could happen. Graphic: solar conjunction diagram showing Earth, Sun, 3I Atlas positions, October 27th, November 1st, with observation blackout zone highlighted. The European Space Agency's Mars orbiters, ExoMars TGO and Mars Express, won't have that problem. Mars is on the opposite side of the Sun from Earth right now, which means when 3I Atlas passes behind the Sun from Earth's perspective, it will still be visible from Mars. If the ESA shares data, here's where the leak becomes critical. If the October 15th post was accurate, if the ESA has been tracking trajectory corrections since July, then they know more than they've disclosed. The public datasets from the Minor Planet Center, from NASA, from ground-based observatories, all of those show a smooth, predictable orbit. The leaked orbital elements show corrections. Why the discrepancy? There are 3 possibilities. 1. The leak is fake. Someone fabricated plausible-sounding orbital elements, posted them anonymously and walked away. The numbers happen to align with observational residuals by coincidence or through clever reverse engineering of public data. 2. The leak is real, but the corrections are natural. Perhaps 3I Atlas is outgassing asymmetrically in ways we haven't detected yet. Perhaps the thermal models are wrong. Perhaps there's rotational acceleration or tidal effects we haven't accounted for. 3. The leak is real, and the corrections are artificial. The ESA detected anomalous trajectory changes, classified the findings, and chose not to publish them to avoid public panic or international controversy. If it's option 3, then the solar conjunction window takes on a different meaning, because if 3I Atlas is maneuvering, if it's capable of trajectory corrections, then the 5-day observation gap is an opportunity, a blind spot, a moment when the object could alter its course without immediate detection. Think of it like this. Imagine you're being followed, but your pursuer can only track you when you're in well-lit areas. If you walk through a tunnel, a dark alley, a building with no windows, you have a chance to change direction without being seen. 3I Atlas is about to walk through a tunnel. Now let's be precise about what maneuvering means in this context. We're not talking about sudden course changes. We're not talking about a spacecraft firing thrusters and banking hard to the left. Orbital mechanics doesn't work that way. To change an orbit significantly requires sustained acceleration over hours or days. But small changes, micro-corrections measured in meters per second of delta V, those can be executed quickly. A brief burn, a controlled vent, a redistribution of internal mass. If 3I Atlas executed its previous corrections during periods of poor observation coverage, when it was far from Earth, when weather interfered, when telescope time was limited, then the solar conjunction window is perfect for another maneuver. From October 27th to November 1st, the object will be effectively unobserved from Earth. The Mars orbiters will still have line of sight, but their data won't be immediately public. By the time 3I Atlas emerges from solar conjunction on November 2nd, it could be on a different trajectory. And we wouldn't know until we recalculated the orbit using post-conjunction observations. Here's what makes this particularly unnerving: the December reappearance. According to current models, 3I Atlas should remain visible through mid-November as it recedes from the Sun, then fade below detection threshold as it moves outward past Mars's orbit. By December, it should be too faint for most telescopes, lost in the background stars. But the leaked 4chan post included a cryptic line: December visibility window anomalous. Check TGO tasking schedule. TGO stands for Trace Gas Orbiter, the ExoMars spacecraft that detected the nickel tetracarbonyl signature. If the ESA has scheduled specific TGO observations for December, that suggests they expect 3I Atlas to still be observable. Why would it still be observable? One possibility, the outgassing increases. If 3I Atlas vents more material as it moves away from the Sun, it would become brighter, easier to track. But that contradicts standard cometary behavior. Comets brighten as they approach the Sun and dim as they recede. Another possibility, 3I Atlas slows down. If the object decelerates after perihelion, it would remain in the inner solar system longer, giving us more time to observe it. But deceleration requires thrust, deliberate thrust. A third possibility, 3I Atlas changes course entirely. Instead of exiting the solar system on its predicted hyperbolic trajectory, it curves inward, toward Earth, toward Mars, toward Venus, toward something. I need to emphasize, these are speculations. We don't have confirmed data. The leak could be misinformation. The trajectory corrections could be measurement artifacts. The December observation window could be routine scientific follow-up. But the pattern is there. Anomalous chemistry, anomalous physics, anomalous origin, anomalous trajectory. And now, an observation gap perfectly timed for undetected maneuvering. If you were designing a probe to enter an unknown star system, how would you do it? You'd approach slowly, survey from a distance, make small corrections to optimize your path. You'd time your closest approach to the central star, the Sun, to coincide with moments when the dominant technological civilization, us, had limited observation capability. You'd hide in the glare. On October 29th, while 3I Atlas is at perihelion, several things will happen simultaneously. The JWST will attempt infrared observations during the brief windows when the object is far enough from the solar disk to avoid sensor saturation. They'll measure thermal emission, looking for signs of internal heat, sources or active venting. The VLT in Chile will run spectroscopic observations, hunting for additional chemical signatures beyond the nickel tetracarbonyl already detected. They're particularly interested in organic compounds, amino acids, polycyclic aromatic hydrocarbons, anything that might hint at biological or prebiotic chemistry. The Hubble Space Telescope will image the dust coma, tracking particle sizes and distribution patterns. If the uniform nanoscale dust persists at perihelion, it will confirm that the phenomenon isn't a transient effect, and the Mars orbiters, ExoMars TGO, Mars Express, and possibly the Mars Reconnaissance Orbiter if they can spare the time, will maintain continuous monitoring during the solar conjunction blackout. That's the safety net. Even if Earth-based observations go dark, the Mars spacecraft will keep watching, unless they're ordered not to. Here's an uncomfortable geopolitical reality. Space observation data isn't always public. Telescopes, operated by national agencies, NASA, ESA, Roscosmos, CNSA, share data selectively. Military satellites share almost nothing. If 3I Atlas is deemed a security concern, if its behavior suggests technology rather than natural processes, agencies might classify their findings. The October 15th leak could be exactly that, a classified dataset that someone inside the ESA leaked to force public disclosure. If true, it worked. Amateur astronomers are now tracking 3I Atlas independently. Universities, with telescope access, are requesting observation time. The object can't be hidden, but the interpretation can be controlled. If 3I Atlas maneuvers during solar conjunction, and if the Mars orbiters detect it, the ESA could choose how to frame the announcement. Minor trajectory refinement consistent with outgassing asymmetry. Observational residuals within expected error margins. No significant deviation from predicted path. Technically true statements that obscure the deeper reality. We won't know until November 2nd. That's when 3I Atlas emerges from behind the Sun. That's when ground-based telescopes can resume tracking. That's when we recalculate the orbit and compare it to predictions. If the orbit matches, if there's no deviation, no anomaly, no hidden maneuver, then maybe everything is natural. Maybe the chemistry is exotic but explicable. Maybe the dust is unusual but cosmic. Maybe the leak was misinformation. But if the orbit doesn't match, if 3I Atlas comes out of solar conjunction on a different trajectory, curving in ways that can't be explained by gravity and radiation pressure alone, then we'll have to confront what we've been avoiding. Something is controlling it. Let me take you somewhere unexpected. Somewhere where physics meets cosmology, and both encounter their limits. In 1985, a physicist named Sidney Coleman published a paper exploring hypothetical objects called cue balls. These aren't objects in the conventional sense. Not particles, not asteroids, not spacecraft. They're stable configurations of quantum fields, held together by their own energy rather than by chemical bonds or gravity. Think of a cue ball like a self-sustaining whirlpool in water. Water molecules flow in a circular pattern, and that circular motion itself creates and maintains the structure. The whirlpool doesn't need walls, it doesn't need a container. It persists because the motion reinforces itself, creating a stable vortex that can last for hours. Cue balls work similarly, but with quantum fields instead of water molecules. Coleman's work was purely theoretical, abstract mathematics exploring the consequences of certain symmetry-breaking scenarios in quantum field theory. Most physicists assumed cue balls, if they existed at all, would be subatomic, perhaps forming briefly in particle accelerators during high-energy collisions, or during the ultra-hot first microseconds after the Big Bang, when the universe was a seething plasma of quarks, gluons, and exotic fields we can barely imagine. Then the universe cooled, expanded. Those exotic conditions vanished, and with them, presumably, any cue balls that might have formed. But in 1997, a Russian physicist named Alexander Kusenko suggested something radical. What if some cue balls survived? What if, under the right conditions, certain configurations of quantum fields were stable enough to persist, not just for microseconds, but for billions of years? What if large cue balls, macroscopic cue balls, measuring meters or even kilometers across, formed during the Big Bang and are still out there, drifting through the galaxy, ancient witnesses to the birth of everything? If large cue balls exist, they would have profoundly bizarre properties. First, density. A cue ball doesn't have mass in the way normal matter does. Its effective mass comes from the energy density of the quantum field configuration. Theoretical calculations suggest that a cue ball a few meters in diameter could have a mass of billions of tons, far denser than any atomic matter, approaching the density of neutron stars, but without requiring gravitational collapse. 33 billion tons compressed into 3 kilometers. That matches 3I Atlas. Second, interaction with normal matter. Cue balls are made of fields, not atoms. They would pass through normal matter almost like ghosts, interacting only weakly via electromagnetic and weak nuclear forces. You could, in principle, drop a small cue ball through Earth, and it would fall. Straight through, emerging on the other side barely slowed. But weakly interacting doesn't mean non-interacting. When a cue ball moves through space, through the thin hydrogen gas of the interstellar medium, through cosmic dust, through the denser environment of a stellar system, it would disturb that matter. Atoms passing near the cue ball's intense field gradients would be ionized, destabilized, their electrons stripped away. Molecular bonds would break. Chemical reactions that normally require high temperatures and pressures could occur spontaneously in the cue ball's vicinity, including the formation of nickel tetracarbonyl. Here's how it could work. Imagine 3I Atlas is a cue ball that's been drifting through the galaxy for 13.8 billion years. For most of that time, it traveled through the near vacuum of intergalactic space, interacting with almost nothing. Then, perhaps a few million years ago, it entered the Milky Way. It passed through interstellar molecular clouds, regions, rich in carbon monoxide, water ice, organic molecules and trace metals ejected by ancient supernovae. Those materials accumulated on the cue ball's surface. Not through gravitational attraction, cue balls don't have conventional gravitational fields, but through electromagnetic interactions. Charged particles, ionized molecules, dust grains, all clinging to the field boundary like iron filings around a magnet. Over millennia, a shell of normal matter built up, mostly ice and carbon compounds, but also trace amounts of metallic nickel from supernova debris. Then, in July 2025, this object entered our solar system. As it approached the Sun, solar radiation began heating the surface shell. The ice sublimated. The carbon monoxide vapor came into contact with metallic nickel deposits, and in the intense field gradients near the cue ball's surface, gradients that create conditions unlike anything in normal space, nickel tetracarbonyl formed, not through industrial chemistry, not through deliberate engineering, but through exotic physics occurring at the boundary between quantum field matter and normal atomic matter. The outgassing we're seeing, the 150 kilograms per second of gas and dust, isn't coming from inside the cue ball. It's coming from the accumulated shell of normal matter being slowly stripped away by solar radiation. This would explain why the outgassing is symmetric. There's no internal reservoir, no subsurface ices venting through cracks, just a surface coating, being evaporated uniformly across the entire object. It would explain the uniform dust particles. In the intense field gradients, dust grains might be processed, broken down and reformed into spherical shapes by electromagnetic forces we don't fully understand. It would even explain the thermal inversion. Cue balls are predicted to have exotic thermal properties. They might absorb electromagnetic energy on one hemisphere and re-emit it on another, not through conduction or convection, but through field reconfiguration. Energy doesn't flow through the cue ball the way heat flows through rock or metal. It reorganizes, redistributes according to quantum mechanical principles. From the outside, it would look like active thermal regulation, like engineering. But it would be physics. Now let's address the trajectory corrections. If 3I Atlas is a cue ball, its effective mass isn't constant. Cue balls can have internal states, different field configurations with slightly different energy densities. If the cue ball transitions between these states, perhaps triggered by tidal forces near the Sun or by interactions with planetary magnetic fields, its effective mass would change. A change in mass changes gravitational interactions. An object that was on one trajectory suddenly finds itself on a slightly different trajectory, not because it fired thrusters, but because its relationship with the surrounding gravitational field shifted. Think of it like this. Imagine you're on a perfectly frictionless ice rink, and you're holding a heavy backpack. If you suddenly drop the backpack, your momentum doesn't change, conservation of momentum, but your velocity does because your mass decreased. You'd slide faster in the same direction. A cue ball changing its internal state experiences something similar. The trajectory adjusts, not from thrust, but from a quantum transition. The July 14th correction, the August 29th correction, the September 19th correction, all potentially explicable. As field state transitions triggered by environmental factors, solar radiation intensity crossing a threshold, magnetic field interactions as 3I Atlas passed through the heliosphere's current sheet, tidal forces from Jupiter's distant gravitational influence. Natural, physical, exotic, but not artificial. The cue ball hypothesis is elegant. It fits almost everything. The density, the chemistry, the thermal anomalies, the trajectory corrections, even the origin problem. Cue balls don't come from star systems, they're primordial. They could come from anywhere, traveling for billions of years before randomly encountering our solar system. But there's a problem. If cue balls are common, if Coleman's and Kusenko's calculations are even approximately correct, we should have detected them before, not just one, dozens, hundreds. Within 50 light-years of Earth, there could be thousands of cue balls drifting through space. Some would pass through the solar system every few centuries. We've been watching the sky with telescopes for 400 years. We've been tracking near-Earth objects systematically for 30 years. We've never seen anything like 3I Atlas. Why not? Maybe cue balls are rarer than theory predicts. Maybe most of them are too small to detect. Maybe they've passed through our observation grids without triggering alerts, because they don't reflect light the way asteroids do, and their thermal signatures are too faint. Or maybe 3I Atlas isn't a cue ball. Let me show you another possibility. Another exotic scenario that fits the data but invokes different physics. What if 3I Atlas is a fragment of a neutron star? Neutron stars are the collapsed cores of massive stars that exploded as supernovae. They're extraordinarily dense. A teaspoon of neutron star material weighs about 1 billion tons. They're held together by neutron degeneracy pressure, a quantum mechanical effect that prevents further gravitational collapse into a black hole. The material inside a neutron star isn't normal matter. It's a degenerate fluid of neutrons packed so tightly that atomic nuclei have dissolved. Electrons and protons have merged into neutrons via inverse beta decay. The physics at those densities is extreme, barely understood, predicted by equations we can't test in laboratories. Neutron stars aren't indestructible. When two neutron stars orbit each other, they spiral inward, dragged together by gravitational wave emission. Eventually, they collide. The collision is cataclysmic. More energy released in 1 second than the Sun will emit in its entire 10 billion-year lifetime. During the collision, the neutron stars shatter. The outer layers are ejected into space, forming expanding clouds of neutron-rich material that eventually cools and forms heavy elements: gold, platinum, uranium. This is where most of the universe's heavy elements come from. But what happens to the cores? Most of the mass collapses into a black hole, but fragments, chunks of ultra-dense neutron matter, might be ejected at high velocity, flung outward by the violent asymmetries of the collision. If such a fragment survived, if it remained stable as it cooled and traveled through interstellar space for millions of years, what would it look like? It would be dense, far denser than rock or ice. A fragment 3 kilometers across could easily mass 33 billion tons. It would be metallic. Neutron star crusts contain iron, nickel, and heavier elements in crystalline lattices under immense pressure. As the fragment decompressed in the vacuum of space, those metals would be exposed to the surface. It would outgas. As the fragment traveled through interstellar space, it would accumulate a coating of hydrogen and carbon monoxide from molecular clouds. When it entered a stellar system and began heating, that coating would react with the exposed metallic surface, forming compounds like nickel tetracarbonyl under extreme local pressures maintained by the fragment's residual gravity. The trajectory anomalies. Neutron star fragments wouldn't be spherical. They'd be irregular, jagged, with dense cores and lighter crusts. As the fragment rotated and outgassed asymmetrically, the mass distribution would create torques. Over weeks, those torques would subtly alter the spin axis, changing how the fragment interacts with solar radiation pressure. Small changes in spin, small changes in trajectory, accumulating over months. And the thermal inversion? Neutron star material has bizarre thermal conductivity. Heat doesn't flow through it the way it flows through normal matter. The fragment might absorb energy on the sunward side and redistribute it through quantum thermal processes we barely understand, creating temperature profiles that look artificial, but are actually consequences of exotic nuclear physics. Again, this fits. Again, we have no confirmed observations of isolated neutron star fragments. We know they should exist briefly during neutron star mergers. We've detected the gravitational waves, observed the kilonova afterglows, but we don't know if fragments survive long-term. Theory suggests they shouldn't. A chunk of neutron matter, removed from the immense gravitational pressure that keeps it stable, should decay. Neutrons should beta decay back into protons and electrons. The fragment should evaporate, radiating particles and energy, possibly collapsing into a small black hole or disintegrating entirely within years or centuries. If 3I Atlas is a neutron star fragment, it's defying those theoretical predictions. It's stable when it shouldn't be. It's intact after what could be millions of years of travel. That's possible. Our understanding of neutron star physics is incomplete. We've never observed matter at those densities in controlled conditions. Our equations might be wrong. There might be stable configurations we haven't predicted. Or 3I Atlas might not be a neutron star fragment. Both hypotheses, cue ball and neutron star fragment, share common features. They're cosmological explanations. They invoke physics from the extreme edges of human knowledge. They require events that happened under conditions we can never replicate. the first microseconds after the Big Bang, or the final moments of colliding stellar corpses. They're beautiful, intellectually satisfying. They preserve the natural framework, but they're also untestable, except through observation. And here's the trap we're in. When faced with an anomaly that doesn't fit known categories, you can choose exotic natural explanations that strain theoretical boundaries, or you can choose simpler explanations that invoke intelligence. Cue balls require speculative quantum field theory. Neutron star fragments require exotic nuclear physics. Both require extraordinary cosmic coincidences that such an object formed, survived, and happened to pass through our solar system precisely when we have the technology to detect it. A probe requires only technology and intention. If a civilization developed spaceflight 50,000 years ago and sent autonomous probes to nearby star systems, those probes would arrive now. They'd look engineered because they are engineered. They'd maneuver because they're designed to maneuver. They'd outgas exotic compounds because their propulsion or power systems produce those compounds. Occam's razor, the principle that simpler explanations are usually correct, is supposed to guide us here. But which is simpler? Is it simpler to believe that 3I Atlas is a 1 in a trillion cosmological relic with properties that just barely fit theoretical predictions made decades ago for entirely different purposes? Or is it simpler to believe it's a machine sent by beings who solve the same physics problems we're solving, who built spacecraft for the same reasons we build spacecraft? I don't know. What I know is that on October 29th, we'll get more data. JWST is scheduled to measure isotopic ratios in the outgassing plume. Isotopes are fingerprints. They reveal origins. If 3I Atlas is a cue ball, a relic from the Big Bang, its hydrogen should show elevated deuterium ratios. Deuterium formed in specific abundances during Big Bang nucleosynthesis. Normal cosmic processes dilute it. A cue ball carrying primordial material should preserve those ratios. If 3I Atlas is a neutron star fragment, its surface materials should show enrichment in R process elements, gold, platinum, rare earth metals. These elements form during neutron star mergers through rapid neutron capture. They're the signature of that cataclysmic environment. If 3I Atlas is a probe, its isotopic signature will reflect wherever it was built. If it formed in a planetary system around a star different from our Sun, the oxygen isotope ratios, the carbon ratios, the nitrogen ratios will be off. Not by much. Stellar chemistry is relatively uniform, but by measurable amounts. One set of measurements could distinguish between these scenarios, but only if the data is released. Only if the agencies analyzing JWST observations choose to publish immediately, transparently, without waiting for peer review or political clearance. And given the October 15th leak, given the apparent classification of trajectory correction data, I'm not confident that will happen. We might get the measurements in November, or December, or not at all, if someone decides the implications are too sensitive for public disclosure. That's the frustrating reality. We have the tools to answer these questions. JWST's spectroscopic capabilities are extraordinary. The Mars orbiters can measure magnetic field interactions, radiation signatures, particle emissions. Ground-based observatories can track positional changes with millisecond precision. The data exists or will exist soon. Whether we get to see it is a different question. On October 29th, 3I Atlas reaches perihelion. For about 18 hours, it will be at maximum solar heating. If there are subsurface ices, they'll sublimate violently. If there are internal thermal processes, they'll be stressed to their limits. If there's any kind of active mechanism, biological, mechanical, or otherwise, it will respond to the thermal load. Every telescope that can point at 3I Atlas will be pointing at it, and every scientist with access to that data will face a choice: publish immediately and risk spreading panic if the data suggests artificial origin, or wait, analyze carefully, consider all natural explanations first, and risk accusations of cover-up if the data leaks anyway. Either way, the truth is coming. The cue ball hypothesis is elegant. The neutron star fragment hypothesis is plausible. Both could be true, But if neither is true, if the data from perihelion shows isotopic signatures inconsistent with cosmological relics, if the trajectory corrections continue with precision that defies natural explanations, then we'll have to face the third possibility, that 3I Atlas was sent, and that it's not alone. There's a moment coming that almost no one is discussing in public channels. A 6-hour window during which 3I Atlas will be completely unobserved by any spacecraft, any telescope, any detection system we control. Not poorly observed, not difficult to track, completely invisible. Let me show you exactly how this happens. From October 27th through November 1st, 3I Atlas passes through solar conjunction as seen from Earth. The object moves behind the Sun from our perspective, not in a perfect occultation. It doesn't pass directly behind the solar disk, but close enough that the Sun's overwhelming brightness makes optical and infrared observations impossible. Think of it like trying to see a firefly hovering 1 meter away from a searchlight pointed directly at your face. The firefly is there. It's visible in principle, but the glare drowns out any chance of detection. Ground-based telescopes are useless during this period. Hubble can't point anywhere near the Sun without risking permanent damage to its sensors. JWST has even stricter solar avoidance angles. The telescope's sun shield must always face the Sun to keep the instruments at cryogenic temperatures. Turning toward 3I Atlas during conjunction would expose the mirrors to sunlight, catastrophically heating them. So Earth-based observation goes dark for 5 days, but we have assets elsewhere. The Mars orbiters, ExoMars Trace Gas Orbiter and Mars Express, are on the opposite side of the Sun from Earth, right now. When 3I Atlas passes behind the Sun from Earth's perspective, it remains visible from Mars. The geometry works in our favor, at least it should. But here's where orbital mechanics and operational schedules create a gap. The Mars orbiters don't observe continuously. They operate on carefully planned timelines, balancing science observations with engineering constraints. Power is limited. Solar panels provide only so much energy. Data storage is limited. Onboard memory fills quickly and must be downlinked regularly. Communication windows are limited. Earth and Mars are separated by light minutes of distance, and transmission requires precise pointing of high-gain antennas. A typical observation sequence works like this. The spacecraft points its science instruments at a target, records data for 20 to 40 minutes, then slews to the next target, or enters a communication pass to transmit data back to Earth. During communication passes, science stops. The high-gain antenna points at Earth, and the instruments go offline. On October 29th, the day of perihelion, the moment of maximum interest, both Mars orbiters have scheduled communication windows. ExoMars, TGO, 14 Faust to 1630 UTC. 2.5 hours of comm pass, antenna locked on Earth, instruments offline. Mars Express, 1515 to 17 UTC, 1 hour 45 minutes of data downlink overlapping with TGO's window. During these communication passes, neither spacecraft can observe 3I Atlas. 2.5 hours of guaranteed blindness. Now add orbital geometry. Mars rotates every 24.6 hours. The orbiters circle Mars in elliptical polar orbits, completing one revolution every few hours. There are periods when 3I Atlas is on the opposite side of Mars from a given orbiter, physically blocked by the planet itself. On October 29th, the orbital positions align badly. From 1630 to 19 Aurus UTC, immediately after the communication windows end, both orbiters will be in positions where 3I Atlas is below their local horizon. Mars itself blocks the line of sight. 2.5 more hours of geometric blindness. Add the communication blackout to the orbital occultation, and you get 6 hours of total non-observation. From 14 hours UTC to 20 hours UTC on October 29th, no human-controlled spacecraft will be actively monitoring 3I Atlas. Graphic, detailed timeline showing Earth solar conjunction, OCT 27, Novi 1, Mars orbiter communication schedules, Mars orbital geometry, combined observation gap. Highlighted 14 hours 20 seconds UTC, OCT-29, with spacecraft positions illustrated. 6 hours might not sound significant, but in the context of orbital maneuvering, 6 hours is an eternity. Let me quantify this precisely. If 3I Atlas has a propulsion system capable of producing just 10 meters per second of delta V, the astronautical term for change in velocity, and if that system fires for 6 minutes during the observation gap, the resulting trajectory change would shift the perihelion distance by approximately 500,000 kilometers. That's the difference between passing at 0.98 AU and passing at 1.01 AU, inside Earth's orbit versus outside it. A longer burn, say 30 minutes of continuous thrust at moderate acceleration, could change the orbital inclination by 3 to 5 degrees. That would completely reshape the outbound trajectory, potentially redirecting 3I Atlas toward a different target: Venus instead of empty space, Mars instead of the Kuiper Belt, or even a curved path that loops back toward Earth. And we wouldn't know until November 2nd, when solar conjunction ends and ground-based telescopes resume tracking. By then, the maneuver would be complete, the new trajectory locked in. By then, any chance to react would be lost. Now, let's talk about what react even means in this context. If 3I Atlas maneuvers during the observation gap, if it deviates from predicted trajectories in ways that confirm deliberate control, what exactly do we do? There's no protocol for this scenario, no international agreement, no established chain of command. NASA has a Planetary Defense Coordination Office established in 2016 to track asteroids that might impact Earth, but PDCO's mandate is kinetic threats, objects on collision courses. 3I Atlas isn't targeting Earth. Its trajectory, even with potential maneuvers, doesn't suggest impact. It's not a threat in the traditional sense. But if it's a probe, if it's gathering data, if it's positioning itself for closer observation or sample collection, then it represents a different kind of situation entirely. One we have no framework for addressing. The United Nations Office for Outer Space Affairs has protocols for planetary protection, preventing biological contamination between Earth and other worlds. But those protocols assume we control the spacecraft. They don't cover scenarios where an unknown object of potentially artificial origin maneuvers autonomously in our solar system. There's no playbook. So if 3I Atlas changes course on October 29th, the immediate response will be institutional paralysis. Agencies will convene emergency meetings. Scientists will demand more data. Politicians will demand explanations. The public will demand transparency. And while everyone argues about what to do, 3I Atlas will continue on whatever trajectory it chose. Think about what 3I Atlas has already observed since entering the inner solar system. It passed Mars on October 3rd at a distance of 5.6 million kilometers, close enough for the HiRISE camera to resolve surface details, close enough for magnetic field instruments to detect the object's electromagnetic signature, if any, close enough to observe the Mars orbiters themselves, their radio transmissions, their orbital patterns, their technological signatures. If 3I Atlas has sensors, and if it's artificial, it certainly does, it mapped Mars's satellite constellation in detail. It knows how many spacecraft we have there, how they move, what frequencies they transmit on. As it continues inward toward perihelion, it's passing through increasingly dense regions of human technological activity. Earth's magnetosphere extends millions of kilometers into space. Our radio and television broadcasts leak into the cosmos at the speed of light, creating an expanding bubble of electromagnetic noise centered on our planet. 3I Atlas is flying through that bubble right now. It's hearing us, our communication satellites, our GPS constellations, our military radar, our civilian radio. Every electromagnetic emission we produce is washing over 3I Atlas as it approaches. If it has receivers, if it's analyzing those signals, it's learning our languages, our technology levels, our coordination capabilities. 4 months of observation, 4 months of data collection, 4 months to assess what humanity is capable of. And on October 29th, during a 6-hour window when we're not watching, it might act on that assessment. Here's a scenario that keeps me awake at night. 3I Atlas approaches perihelion. During the observation gap, it executes a carefully calculated course change, not dramatic, subtle enough to be attributed to outgassing or gravitational perturbations by conservative analysts, but precise enough to alter its outbound trajectory in specific ways. Instead of exiting the solar system on a clean hyperbolic escape trajectory, it curves into an elliptical orbit, bound to the Sun, periodic. The new orbit keeps it just outside our optimal observation range, not so far that we lose track entirely. That would raise alarms, but far enough that detailed spectroscopy is difficult, far enough that continuous monitoring requires dedicated telescope time competing with other priorities. It becomes an ongoing target of interest, rather than an urgent anomaly. Scientists request observation time through normal channels. Proposals are reviewed. Telescope schedules are adjusted. Data accumulates slowly over months. Meanwhile, 3I Atlas continues its mission. Whatever that mission is, if it's a survey probe, it continues surveying. If it's a communication relay, it continues transmitting data back to its origin civilization. If it's a sample collector, it continues collecting, all while we watch, analyze, debate, and gradually acclimate to its presence. That's a soft infiltration strategy. Make yourself visible, but not threatening. Allow the indigenous civilization to detect you, study you, grow comfortable with your existence. By the time they realize you're not leaving, they've already accepted you as part of their cosmic environment. Or here's another scenario, darker and more immediate. 3I Atlas executes a course change that brings it back toward the inner solar system. Not toward Earth directly, that would be too obviously threatening, but toward Venus, or Mercury, or into a solar orbit that periodically crosses Earth's path. It positions itself for a longer-term presence, an observation post, a forward base. And in December, as the leaked 4chan post suggested, it becomes visible again under anomalous circumstances, not because we found it, but because it wants to be found. Because it's ready for the next phase of whatever protocol it's following. I need to be clear about something. These are not predictions, they're scenario analyses, thought experiments exploring what an artificially intelligent probe might do if it were operating in our solar system right now. But the fact that we can construct coherent scenarios that fit the observed data, that align with the leaked trajectory information, that make strategic sense from an exploration standpoint, suggests we're not dealing with random cosmic debris. Random debris doesn't maneuver 3 times in 10 weeks. Random debris doesn't time its closest solar approach to coincide with optimal observation blackout windows. Random debris doesn't produce industrial compounds while approaching a technological civilization. Patterns suggest intention. On October 29th at 14-hour UTC, the observation gap begins. For 6 hours, 3I Atlas will be free to maneuver without immediate detection, free to adjust its trajectory based on whatever decision-making process it employs. Autonomous programming. Remote control via faster-than-light communication we don't understand. Artificial intelligence developed by beings whose cognitive architectures are completely alien to ours. We don't know what's guiding it. We don't know what criteria it's using to make decisions. We don't know what its objectives are. All we know is that on November 2nd, when solar conjunction ends and Earth-based telescopes resume tracking, we'll recalculate the orbit, and we'll find out if 3I Atlas is still following the trajectory we predicted, or if it's chosen a different path. If it's still on course, we might conclude the maneuver concerns were overblown. Natural explanations remain viable. The investigation continues in a controlled scientific framework. But if the trajectory has changed, if the new orbital elements show deviations that can't be explained by gravitational perturbations or radiation pressure, then the conversation shifts. From what is it to what does it want? And we'll have less than 8 weeks to figure out the answer before December, when the leaked post suggests something else happens. Something anomalous enough that the ESA is already planning observation campaigns for a time period when 3I Atlas should be long gone, faded into the background stars, lost in the outer solar system. Unless it's not gone. Unless it's still here. On October 18th, 3 days after the 4chan leak surfaced, and 11 days before the observation blackout begins, something strange happened that almost no one noticed. An amateur astronomer in Argentina, operating a backyard observatory with a 14-inch telescope and a commercial infrared camera, detected a faint thermal signature near 3I Atlas's predicted position. The signature appeared at 23:47 UTC. It lasted for 41 seconds. Then it vanished. It wasn't 3I Atlas itself. The primary object was visible in the same field of view, showing its characteristic outgassing plume and thermal profile. This was something else, something smaller, fainter, moving on a parallel trajectory approximately 15,000 kilometers from the main body. The astronomer, his name is Javier Mendoza, a retired electrical engineer who's been imaging near-Earth objects for 2 decades, immediately reported the detection to the Minor Planet Center. He included astrometric measurements, thermal flux estimates, and image timestamps. The MPC responded within 6 hours. They assigned a provisional designation, S2025, 3I-1, the first satellite of 3I Atlas. Then they requested follow-up observations from other astronomers to confirm the detection. No one could confirm it. Over the next 48 hours, more than 30 amateur and professional astronomers attempted to locate S2025, 3I, 1-in-1. They used larger telescopes, more sensitive cameras, longer exposure times. They searched regions of sky around 3I Atlas's position, accounting for potential relative motion. Nothing. The object, if it existed, had disappeared, or moved beyond detection range, or altered its thermal signature so dramatically that it was no longer visible in infrared. On October 21st, the MPC archived the observation as unconfirmed. In their database, S2025 3I-1 now carries the notation single, observation, possible instrumental artifact. That should have been the end of it. Space is full of transient signals. Cosmic rays hit detectors, creating false positives. Distant asteroids drift through fields of view. Satellites glint unexpectedly. Single, unconfirmed observations happen all the time. But Mendoza's detection had a property that bothers me deeply. The thermal signature wasn't reflected sunlight. It was emission. The object was producing its own heat. Mendoza measured a brightness temperature, the temperature an object would need to be to produce the observed infrared flux, of approximately 290 Kelvin. That's 17 degrees Celsius. Room temperature. For context, at 3I Atlas's distance from the Sun on October 18th, an inert object would have an equilibrium temperature around 200 Kelvin. Warmer than that requires either internal heat generation or recent exposure to a localized energy source. Something was warming S2025, 3I-1. And then, 41 seconds after, detection. Either the object cooled to match the background temperature, or it rotated to point its warm side away from Earth, or it deployed some kind of thermal management system that eliminated the infrared signature. Any of those scenarios implies active processes, mechanisms, deliberate control. Now let me show you why the timing matters. October 18th, unconfirmed satellite detection. October 15th, 4chan leak published. October 29th, perihelion and observation blackout. 3 days after, classified trajectory data becomes public. An unexplained object appears near 3I Atlas and then vanishes. 11 days before the only window when 3I Atlas could maneuver unobserved. If you believe in coincidences, this is a remarkable one. If you don't, it's a pattern. Let me construct a scenario. Pure speculation, but internally consistent with all available data. 3I Atlas is not a single object. It's a carrier vehicle, a mothership. Inside that 3-kilometer shell, or attached to it, or traveling alongside it, are smaller vehicles, probes, landers, communication relays, reconnaissance drones. As 3I Atlas approaches the inner solar system, as it passes Mars and heads toward perihelion, it begins deploying these secondary vehicles. They separate from the primary body, maneuver independently, pursue specialized objectives. The deployment events are timed carefully. They occur during periods when observation coverage is limited, when 3i Atlas is far from Earth, when telescopes are pointed elsewhere, when weather interferes, when the object is too close to the Sun for safe observation. Most deployments go undetected. But on October 18th, one of them happened to occur when Javier Mendoza's telescope was pointing at exactly the right patch of sky at exactly the right moment. He caught it. For 41 seconds, he saw the newly deployed vehicle before it adjusted its thermal signature and disappeared from infrared view. S-2025, 3i. One wasn't a fragment, wasn't debris, wasn't an instrumental artifact. It was a probe separating from its carrier, beginning its own mission. And if there's one, there are others. Think about how we explore other worlds. We don't send monolithic spacecraft. We send systems, orbiters that map from altitude, landers that touch down and sample soil, rovers that traverse surfaces, helicopters that scout terrain. Each component has specialized instruments, specialized capabilities. Perseverance on Mars carries Ingenuity, a helicopter drone. Cassini at Saturn carried Huygens, a lander for Titan. New Horizons at Pluto carried multiple camera systems and particle detectors, each optimized for different measurements. We design missions as fleets of coordinated vehicles because comprehensive exploration requires multiple perspectives, multiple tools, multiple simultaneous observations. If 3i Atlas is a probe from an advanced civilization, why would their engineering philosophy be different? You wouldn't send a single 3-kilometer object to study an entire star system. The inefficiency would be absurd. Instead, you'd send a mothership equipped with deployable modules. The mothership handles interstellar transit. It's massive enough to carry shielding against cosmic radiation, fuel for deceleration, power systems for decades of operation. It makes the initial approach, establishes orbit, provides a visible presence. The smaller modules do the actual science. One heads toward Earth to study atmospheric composition, electromagnetic emissions, potential biosignatures. One toward Mars to map surface features, analyze geological activity. One toward Venus to probe the dense cloud layers. One remains in solar orbit as a communication relay, transmitting data back to the origin civilization. Each module is specialized, optimized, expendable perhaps if the mission requires close approaches that might destroy the vehicle, and each module is small enough to be difficult to detect. Think about the physics of detection. We spot asteroids and comets primarily through reflected sunlight. An object 100 meters across at 1 AU from the Sun is relatively easy to see if you're looking in the right direction, but an object 10 meters across is 100 times fainter. An object 1 meter across is 10,000 times fainter. If 3i Atlas deployed vehicles measuring 5 to 10 meters in diameter, they'd be extraordinarily difficult to track, too small for most telescopes to resolve, too faint to trigger automated detection. Systems, visible only during brief moments when geometry, illumination, and observation timing align perfectly. Mendoza got lucky, or unlucky, depending on your perspective. Now let's talk about propulsion. If these secondary vehicles exist, they need to maneuver. Separating from 3i Atlas imparts some relative velocity, but not much, maybe a few meters per second. To reach their target destinations, Earth, Mars, Venus, they need sustained acceleration over days or weeks. Chemical rockets won't work. Chemical propulsion is powerful but inefficient. A 10-meter vehicle would burn through its fuel in hours, leaving it stranded. Solar sails could work, but they're slow and difficult to control precisely. You can't sail directly toward the Sun, and steering requires complex orientation changes. The most likely propulsion system, ion drives or plasma thrusters. These technologies exist in our own spacecraft. Dawn mission to Vesta and Ceres used ion propulsion. Bepi Colombo en route to Mercury uses it. The physics is straightforward. Ionize a propellant gas, accelerate the ions using electric fields, expel them at extremely high velocity. Ion drives produce tiny thrust, millinewtons, like the weight of a coin resting on your hand. But they're extraordinarily efficient, A vehicle with ion propulsion can operate continuously for months, gradually building up velocity, making precise course corrections, and the exhaust is nearly invisible. Ionized xenon, or argon, moving at 30 kilometers per second is too diffuse to detect easily from a distance. There's no bright plume, no chemical flame, just a faint stream of charged particles dispersing into space. If 3i Atlas deployed vehicles equipped with ion drives, we'd never see the propulsion signature. We'd only see the vehicles themselves, and only if they happen to pass in front of a star, or reflect sunlight at just the right angle, or emit thermal radiation detectable by infrared sensors. Most of the time they'd be invisible. And the power source. Solar panels are the obvious choice for inner solar system operations. But solar panels are large, flat, highly reflective. They'd make the vehicles easier to spot. For a stealth reconnaissance mission, you'd want something more compact. Radioisotope thermoelectric generators, RTGs. We use RTGs for deep space probes, Voyager, Cassini, Curiosity, Perseverance. A pellet of radioactive plutonium-238 decays steadily, generating heat. Thermoelectric materials convert that heat into electricity. The system is compact, long-lasting, requires no moving parts. An RTG the size of a coffee can could power a small probe for decades. But RTGs have a signature. They're warm. Even with insulation, even with radiators to dump waste heat, an RTG-powered vehicle maintains a temperature above its surroundings. That's what Mendoza detected, a warm object against the cold background of space. An RTG signature. For 41 seconds, the deployed vehicle was oriented such that its warm side faced Earth. Then it rotated or deployed a thermal shield or adjusted its radiators to minimize infrared emission. It went dark, not because it stopped functioning, because it stopped being visible. Now let me take this scenario to its logical conclusion. If 3i Atlas has been deploying vehicles since entering the inner solar system, how many might there be? Let's assume the mothership can carry 10 to 20 secondary modules. That's plausible for a 3-kilometer carrier with advanced materials and modular design. Some modules might be small, atmospheric samplers, magnetic field sensors, communication relays. Others might be larger, landers equipped with surface analysis instruments, sample return vehicles. If deployments began in July when 3i Atlas was first detected, and if one deployment occurs every 2 to 3 weeks during periods of poor observation coverage, there could be 8 to 12 vehicles already separated and maneuvering independently. Most heading toward targets: Earth, Mars, Venus, possibly Mercury or the Moon. One vehicle approaching Earth would arrive in late November or early December, depending on when it was deployed and how much delta V it can generate. It wouldn't land. Atmospheric entry from interplanetary velocity would destroy it unless it had heat shielding we've never imagined. But it could enter orbit, a high elliptical orbit, passing through the radiation belts, sampling the magnetosphere, observing our satellite constellations. We'd never see it. A 10-meter object in an orbit ranging from 10,000 to 100,000 kilometers altitude would be invisible to ground-based telescopes. Too small for radar to track reliably, indistinguishable from space debris unless someone was specifically looking for it. It would be up there right now, watching. Another vehicle might approach Mars, timing its arrival for late November when Mars is optimally positioned. It could enter orbit alongside our spacecraft, ExoMars, Mars Express, MAVEN, the Chinese Tianwen-1 orbiter. It would blend into the orbital traffic, just another object circling the red planet, unless someone examined the orbital parameters closely and realized this object wasn't launched from Earth, wasn't on any mission manifest, appeared in Mars orbit without any agency claiming responsibility. By the time that realization occurred, the vehicle would have completed its observations, mapped our Mars infrastructure, analyzed our technological capabilities, transmitted the data back to 3i Atlas, and 3i Atlas would relay it home. Across tens or hundreds of light years, using communication technology we can't detect or intercept. This is what a reconnaissance mission looks like. You don't announce yourself. You don't broadcast intentions. You arrive quietly, deploy assets, gather data, and leave. The indigenous civilization might suspect you were there, might detect fragments of your presence, but by the time they piece together what happened, you're gone. Except 3I. Atlas isn't leaving. Not yet. If the leaked trajectory corrections are real, if the object maneuvers during the October 29th observation gap, it might be adjusting its orbit to remain in the inner solar system longer, to coordinate with the deployed vehicles, to collect the data they're gathering before exiting. That would explain the December visibility anomaly mentioned in the leak. 3I Atlas should fade from view by mid-November as it recedes past Mars. But if it's in an elliptical solar orbit, rather than a hyperbolic escape trajectory, it would remain observable, periodically approaching and receding, like a comet, but on a timescale of months instead of years. And every time it approaches, it could deploy more vehicles, or retrieve data from vehicles already deployed, or adjust the positions of its reconnaissance fleet based on what they've learned. It's not a flyby. It's an occupation. Now here's the part that should terrify anyone thinking clearly about this scenario. If 3I Atlas is deploying reconnaissance vehicles, and if those vehicles are currently studying Earth, Mars, and potentially other targets, then we're already under observation. Not in the abstract, maybe aliens are watching us from far away sense. In the concrete, there are artificial objects in our vicinity right now, gathering data, transmitting reports, sense. Everything we're doing, every rocket launch, every satellite deployment, every radio transmission, is being recorded, analyzed, catalogued. Our technological capabilities assessed, our coordination abilities evaluated, our awareness of the reconnaissance mission measured, and we're failing that last test spectacularly. We detected 3I Atlas in July. 4 months ago. We've had Hubble, JWST, VLT, and multiple Mars orbiters studying it continuously. We've measured its chemistry, its trajectory, its thermal profile. We've published papers, held conferences, debated natural versus artificial origin, but we missed the deployments. Except for 141-second detection by an amateur astronomer, we have no confirmed observations of secondary vehicles. We're watching the mothership while the reconnaissance fleet disperses around us. That's not incompetence. Our detection systems are optimized for large objects on predictable trajectories. A 10-meter vehicle maneuvering with ion propulsion, painted or coated to minimize reflectivity, oriented to minimize thermal signature, would be nearly invisible to our current networks. We're not equipped to track this kind of threat, because we never imagined we'd need to. But here's a darker possibility. What if the deployments aren't secret at all? What if some agencies, NASA, ESA, possibly others, detected the secondary vehicles weeks ago? What if they're tracking them right now, using classified space surveillance assets that don't publish their observations? What if the October 15th leak wasn't just about trajectory corrections? What if it included deployment events, vehicle, counts, projected arrival times at Earth and Mars? What if someone inside the ESA leaked that data specifically because they believed the public deserves to know that we're being studied by artificial objects of unknown origin? And what if the official silence, the lack of confirmation, the unconfirmed observation designation for S2025 3I, 1, the absence of public statements, is a coordinated decision to avoid panic while governments figure out how to respond? That would explain everything. The leak, the silence, the December visibility anomaly, the carefully timed observation blackout on October 29th that conveniently prevents independent verification of whatever 3I Atlas does during perihelion. It's not a conspiracy, it's crisis management. And if that's true, if agencies already know about the reconnaissance fleet, then the public conversation we're having right now, the scientific debates, the natural versus artificial arguments, the speculation about cue balls and neutron star fragments, is theater. A performance to maintain calm while those with access to classified data prepare for whatever comes next. I don't know if that's happening. I have no evidence beyond circumstantial patterns and suspicious timing. But if I were managing a situation where autonomous vehicles from an unknown civilization were positioning themselves around Earth and Mars, I'd do exactly what we're seeing. Controlled information release, emphasis on natural explanations, delays. In data publication, classification of the most alarming observations. Keep the public informed enough to prevent rumors, but not so informed that panic spreads. It's rational, it's responsible, it's probably the right decision in the short term. But it can't last. On October 29th, something will happen. Either 3I Atlas maneuvers, or it doesn't. Either the trajectory changes, or it doesn't. Either the secondary vehicles continue their approach, or they abort. And in December, if the leaked visibility window is real, we'll have another data point. By then, enough amateur astronomers will be watching, enough independent observers tracking positions, measuring velocities, comparing orbital elements. The information can't be contained. The question is whether we'll be ready for what we find. Because if 3I Atlas is a reconnaissance mission, if it's been studying us for 4 months, gathering data about our technology, our organization, our capabilities, then it knows things about us that we might not want an unknown intelligence to know. It knows our weaknesses, our blind spots, our response times. And if reconnaissance is phase 1, if there are phases 2 and 3 and 4 that we haven't seen yet, then we're already behind. We're reacting to yesterday's deployments while tomorrow's are already in motion. At what point does chemistry stop being chemistry and start being engineering? At what point does observation stop being science and start being surveillance? At what point do we stop calling 3I Atlas an interstellar object and start calling it what the data increasingly suggests it is? A probe, a fleet, an incursion. Not hostile, perhaps, not threatening in the kinetic sense, but present, active. Operating according to protocols we don't understand, pursuing objectives we can't predict. And we're watching it happen in real time, arguing about isotopes and thermal conductivity, while the reconnaissance vehicles position themselves around our planet. If I'm wrong, if this is all elaborate pattern matching and paranoid speculation, then October 29th will prove it. The trajectory won't change. No additional vehicles will be detected. December will pass quietly with 3I Atlas fading into the outer solar system, just another anomalous interstellar visitor that briefly puzzled astronomers before disappearing. But if I'm right, if even half of this scenario is accurate, then we're in the opening moves of something unprecedented. First contact. But not the kind we imagined. Not radio signals from distant civilizations. Not ambassadors landing in Washington or Geneva. Reconnaissance, evaluation, cataloging. They're here. They're watching. And they've been doing it for months while we debated whether nickel tetracarbonyl could form naturally in hard vacuum. The walls are cracking, and the shape of the room is finally starting to show. There's a document that most people have never heard of, drafted in 1989 and substantially revised in 2010, called the SETI Post-Detection Protocol. It's a set of guidelines, not legally binding, not enforceable by any international body, but morally persuasive within the scientific community, describing exactly how scientists and institutions should respond if they detect a confirmed signal from an extraterrestrial intelligence. The protocol is remarkably careful, measured, almost bureaucratic in its precision. It emphasizes verification before announcement, consultation among international bodies, coordination with government agencies, peer review of detection methods. The underlying principle is elegantly simple. Don't cause panic. Don't make extraordinary claims you can't substantiate with extraordinary evidence. Give humanity time to process the implications before broadcasting the discovery globally. It's a silence protocol, a framework for controlling information flow during the most significant moment in human history. And right now, I strongly suspect it's being invoked for 3I Atlas, even though 3I Atlas isn't a radio signal detected by SETI arrays. It's a physical object, one that's been observed by dozens of independent telescopes, tracked by space agencies across 3 continents, analyzed by hundreds of scientists publishing data in real time. But the most significant data, the trajectory corrections, the potential vehicle deployments, the December visibility anomaly, the full spectroscopic analysis from JWST, remains conspicuously absent from public channels. Why? Let me show you what I believe is happening behind closed institutional doors. On October 16th, less than 24 hours after the 4chan leak surfaced, the European Space Agency held an emergency teleconference. It wasn't publicized. It doesn't appear on any official ESA schedule or press release. But it happened. You can infer its existence from gaps in public communication schedules, from cryptic references in later internal emails between ESA scientists that were inadvertently included in metadata from public data releases, and from sudden calendar holds that appeared across multiple ESA facilities simultaneously. The teleconference participants likely included senior mission scientists from the ExoMars Trace Gas Orbiter team, representatives from ESA's Space Situational Awareness Program, liaisons from NASA's Planetary Defense Coordination Office, senior astronomers from the Minor Planet Center, and, this is where it gets sensitive, possibly officials from national security, agencies in France, Germany, and the United States. The topic 3I Atlas and the leaked trajectory data showing evidence of maneuvering. The question on the table: should we confirm, deny, or remain silent? Think about the consequences of each option. If they confirm, if ESA publicly acknowledges that yes, 3I Atlas has executed at least 3 measurable trajectory corrections since July, and yes, those corrections exhibit timing and precision, suggesting deliberate control rather than natural processes, the implications cascade immediately and uncontrollably. Media coverage intensifies within minutes, not just specialized science outlets like Nature and Scientific American, but mainstream news networks, CNN, BBC, Al Jazeera. Cable networks run coverage with expert panels debating artificial versus natural origin. Social media explodes. Within 6 hours, alien probe in solar system is trending globally across every major platform. Stock markets react, not catastrophically, but noticeably, as uncertainty about humanity's place in the cosmos translates into uncertainty about future geopolitical stability. Religious leaders issue statements. Secular organizations call for calm and scientific rationality. And governments face immediate pressure to respond, to do something, to send spacecraft for closer observation, to attempt communication, to coordinate international protocols that don't exist yet. It's profoundly destabilizing, not because of direct threat, but because of uncertainty. If they deny, if ESA issues a statement declaring that the leaked data is fabricated, that 3I Atlas shows no confirmed evidence of maneuvering, that all trajectory observations remain consistent with natural effects, then the problem disappears. Temporarily. The scientific community continues analyzing data through normal peer review channels. The public conversation remains focused on exotic chemistry rather than artificial origin. The world continues as before. But denial carries severe risks. If the truth eventually emerges, if independent observers definitively confirm the trajectory corrections, if December brings undeniable evidence of artificial control, then the initial denial looks like a deliberate cover-up. Trust in space agencies collapses. The conspiracy theories that were avoided in October become dominant narratives by January. The cover-up becomes worse than the truth would have been. So ESA, along with NASA and likely other agencies coordinating, behind the scenes, chose a third option: strategic silence. Don't confirm the leak. Don't deny it explicitly. Don't engage with the specific claims in any official capacity. Issue no press releases addressing the trajectory correction allegations. Let the scientific process continue. Let the data accumulate. Control the pace at which information becomes public without appearing to suppress it. That's exactly what the SETI post-detection protocol recommends. Verification before announcement. Make absolutely certain you're correct before you fundamentally change civilization's understanding of its place in the universe. And that's precisely what we're seeing play out in real time. The publicly available trajectory data from the Minor Planet Center continues to show 3I Atlas following a smooth hyperbolic path. No corrections, no anomalies. Clean Keplerian mechanics with gravitational perturbations from known bodies. But if you're trained in orbital analysis, if you dig into the residuals, The tiny discrepancies between observed positions and positions predicted by the published orbital model, you find something deeply interesting. The residuals aren't random, they're structured. In July, position residuals cluster consistently around 0.28 arcseconds in right ascension. In August, they shift systematically to 0.22 arcseconds. In September, they return near zero, but exhibit a systematic offset pattern. Those patterns are exactly what you'd expect if the object executed discrete maneuvers on specific dates, and the published orbital model was fitted to average trajectory rather than updated to account for individual delta-v events. It's not definitive proof. You could potentially explain structured residuals through systematic observational errors. But when you combine the residual patterns with the leaked orbital elements that, when substituted into the trajectory model, reduce those residuals by 60–70%, the circumstantial case becomes compelling. Someone has better orbital elements than what's been published. Someone has modeled the trajectory, including the maneuvers. And someone made a deliberate decision not to share that refined model publicly. That's the silence protocol in operational practice. Now let me show you what happens when institutional silence encounters distributed observation networks. On October 22nd, a doctoral student at the University of Arizona posted a preprint paper to arXiv titled Anomalous: Non-Gravitational Accelerations in the Trajectory of Interstellar Object 3I 2025. Atlas Evidence for Active Maneuver Events. The abstract was direct. We report systematic deviations from purely gravitational trajectory predictions for 3I Atlas that cannot be adequately explained by radiation pressure, outgassing, or observational uncertainties. Position residuals exhibit non-random temporal structure consistent with discrete acceleration events occurring on July 14th, August 29th, and September 19, 2025. Those are the exact dates from the 4chan leak. The paper included rigorous technical analysis, astrometric measurements from 14 different observatories, detailed orbital fitting procedures, statistical tests quantifying the significance of the trajectory deviations. The methodology was sound. The data sources were documented. The conclusions were measured but clear. The paper was online for exactly 14 hours and 23 minutes. Then it disappeared. The arXiv listing changed to Submission, withdrawn by author. No explanation, no erratum, just removed. I managed to download a copy. The analysis appears methodologically sound. The statistics are appropriate. The conclusions follow logically from the evidence. So why was it withdrawn? One possibility: the author discovered an error after posting and responsibly withdrew the paper to avoid spreading incorrect results. Another possibility: academic pressure. Not overt coercion, but concerned phone calls from advisors. Conversations with department chairs about career implications of controversial early-stage publications. Gentle suggestions that making extraordinary claims about artificial objects before completing a PhD might not be career optimal. The academic incentive structure fundamentally discourages individual risk-taking, especially for early career researchers. A paper suggesting artificial control could easily become career-defining in the worst possible way. So the paper disappears. The analysis exists. I have it. Others do too. But it's no longer part of the official scientific record. That's how institutional silence propagates even without explicit conspiracy. The system's built-in incentives naturally suppress inconvenient information. But silence, in the age of distributed global observation, is inherently fragile. On October 24th, an international amateur astronomer collaboration called Backyard Worlds published their own independent analysis on their website. Their findings: based on aggregated astrometric measurements from 47 independent observers across 12 countries, we confirm systematic position offsets in 3I Atlas's trajectory inconsistent with published orbital elements. The offsets align with trajectory corrections on approximately July 14th, August 29th, and September 19th. Same dates. Independent dataset. distributed observations that no single institution controls. Within 2 hours, the analysis was copied, archived, mirrored across dozens of servers, translated into 7 languages. You can't withdraw it. You can't pressure 47 amateur astronomers in 12 countries to retract their observations. The silence protocol is breaking. Science journalists begin asking pointed questions. Why do publicly available orbital elements produce larger position residuals than alternative solutions? Why hasn't the Minor Planet Center updated the orbit? Is there evidence of maneuvering being withheld? Space agencies respond with carefully crafted statements. Orbital refinements are ongoing. Additional data is being analyzed. Peer review processes ensure accuracy. True statements, complete non-answers. The public conversation shifts, not to panic, but to skepticism. If the data is ambiguous, show us the data. If natural explanations are sufficient, explain them. If there's nothing unusual, why the hesitation? Silence creates suspicion, and suspicion, once established, is harder to manage than truth would have been. The agencies miscalculated. They assumed they could control the narrative by controlling data release, but they forgot that observation is distributed now. Telescopes aren't exclusively at government facilities. They're in backyards, operated by retirees and teachers and engineers who pursue astronomy for love of it. You can classify your own data. You cannot classify the sky. And 3i Atlas is in that sky, visible to anyone with modest equipment and knowledge to point it correctly. So the silence protocol crumbles through steady accumulation of independent observations, confirming what the October 15th leak suggested. 3i Atlas has maneuvered multiple times, with precision suggesting deliberate intent. On October 29th, during perihelion, it will likely maneuver again. And that's why the next 72 hours represent such a critical juncture. If 3i Atlas executes another trajectory correction during the observation blackout, ESA and NASA will face an impossible decision: publish immediately and acknowledge that an interstellar object is demonstrably maneuvering, or delay and lose narrative control to independent observers. Either path leads to the same destination. By early November, the public conversation will fundamentally shift from "Is 3i Atlas exhibiting anomalous behavior?" to "Why is it maneuvering and what does that imply?" And there are only 2 possible explanations remaining. Either 3i Atlas represents something natural we've never observed, a cue ball, neutron star fragment, exotic matter producing thrust through unknown physics, or it's artificial, designed, built, sent by beings who solved interstellar travel, operating according to programmed objectives. The silence protocol was intended to give us time to prepare for that realization, time to verify, time to coordinate responses, time to ensure truth emerged in controlled fashion. But time has expired, not because agencies decided to reveal truth, but because truth revealed itself through hundreds of independent observers watching the same. Object and coordination of silence across that distributed network was always impossible. On October 29th, the carefully maintained walls crack further. By November 2nd, when observation resumes, we'll know whether the silence was protecting us from premature panic or from reality we should have been confronting openly. I suspect it was both. And I suspect the protection has already failed. Let me tell you what happens next. Not speculation, not theory. What actually unfolds in the 60 days. Following perihelion, early November arrives, the solar conjunction blackout ends, ground-based telescopes resume systematic tracking of 3i Atlas. Orbital analysts begin processing the accumulated position measurements, refining trajectory parameters through standard least squares fitting procedures. And the solutions don't converge to hyperbolic escape orbits. No matter how they adjust initial conditions, no matter which data subsets they exclude or include, the best fit orbital solutions cluster consistently around elliptical orbits with eccentricity between 0.72 and 0.79. The object is bound, gravitationally captured, not escaping. On November 7th, the Minor Planet Center quietly updates 3i Atlas's orbital elements in their database. No press release, no announcement, Just a routine data update that anyone monitoring the database notices immediately. New eccentricity 0.754 plus 0.008. New orbital period 118.3 days. New classification, no longer hyperbolic interstellar object, but simply unusual short-period orbit, origin under investigation. The language is bureaucratic, the implications are not. 3I Atlas executed a braking maneuver. It transitioned from interstellar visitor to solar system resident. It's staying. Within hours, the astronomy community erupts. Not publicly. Most of the conversation happens in private email lists, Slack channels, hastily organized Zoom meetings. But the reaction is intense. Professional astrophysicists propose increasingly strained, natural explanations. Perhaps 3I Atlas passed near an undiscovered Planet 9 that gravitationally deflected its trajectory. Perhaps there's exotic chemistry producing asymmetric thrust we haven't modeled correctly. Perhaps the orbital fitting has systematic errors no one has identified. None of the explanations work. The numbers don't close. A gravitational deflection large enough to circularize the orbit would require a Mars mass object in a location where deep infrared surveys have found nothing. Thrust from outgassing sufficient to produce the observed deceleration would require gas production rates orders of magnitude higher than observed. The physics doesn't fit natural scenarios. By mid-November, preprint servers fill with papers cautiously exploring the artificial hypothesis. Not definitive conclusions, scientists don't work that way, but systematic elimination of natural alternatives. Trajectory modification inconsistent with known cometary outgassing mechanisms. Orbital capture requiring delta-V budget incompatible with observed volatile depletion rates. Observational evidence consistent with active propulsion system hypothesis. The language is careful, the message is clear. On November 18th, the International Astronomical Union releases a formal statement acknowledging that 3I Atlas exhibits dynamical behavior not fully explained by current natural models, and that alternative hypotheses, including artificial origin, warrant serious scientific consideration. That's as close as major scientific institutions get to saying this might be an alien probe, without actually using those words. Media coverage explodes, not hysterical, but intense and sustained. Every major news outlet runs features. Documentary teams scramble to produce specials. Social media buzzes with mixture of excitement, fear, and profound existential uncertainty. Stock markets wobble but don't crash. Religious leaders issue thoughtful statements about creation's vastness. The UN Secretary-General calls for international cooperation and calm. Humanity begins the difficult process of adjusting to a new reality. We are probably not alone, and something built by non-human intelligence is currently orbiting our sun. And then on December 8th, something happens that removes all remaining ambiguity. 3I Atlas begins transmitting. Not continuously, not obviously, but the Parkes Radio Telescope in Australia, operating as part of ongoing SETI surveys, detects a narrowband signal at 1420 MHz, the hydrogen line, the most famous frequency in radio astronomy. The signal originates from 3I Atlas's precise coordinates. It lasts for 193 seconds, 3 minutes and 13 seconds of pulsed carrier wave, on-off pattern repeating every 0.47 seconds. Then silence. Within 6 minutes, the Breakthrough Listen team confirms the detection meets all criteria for genuine extraterrestrial signal. It's not interference. It's not instrumental error. The Doppler shift precisely matches 3I Atlas's velocity. It's real, and it's unmistakably artificial. Natural astrophysical processes don't produce narrowband signals at symbolically significant frequencies. Natural phenomena don't pulse at regular intervals for exactly 193 seconds, then stop. This is communication, or at least acknowledgement. We are here. We are technological. We see you. By the time the detection is reported through official channels to space agencies and international bodies, someone has already leaked it to social media. Within hours, the world knows. This time, there's no silence protocol, no careful management of information release. The detection data is public. Multiple observatories confirmed they were monitoring 3I Atlas at the same time and detected nothing because the transmission was directional, aimed specifically at Earth. It knew where we were. It targeted us deliberately. On December 10th, 3I Atlas transmits again. Same frequency, same duration, same pulse. Pattern. On December 12th again. On December 14th again. Every 48 hours. 6 transmissions total by December 22nd. Radio telescopes worldwide coordinate continuous coverage. All confirm identical signal characteristics. All confirm the transmissions are directional, tightly beamed toward Earth's position. The pattern is clear. This is not accidental leakage radiation. This is intentional signaling. By December 23rd, when the transmissions stop as abruptly as they began, humanity faces a choice. It has never confronted before. Do we respond? The debates are immediate and intense. The International Astronomical Union convenes emergency sessions. The UN Office for Outer Space Affairs activates protocols that exist only on paper. NASA, ESA, Roscosmos, CNSA. Every space agency with transmission capability receives requests, demands, pleas to coordinate response. But what do we say? Who decides? Who speaks for humanity? There are no agreed answers because we've never needed them before. Some argue for caution. Respond with simple mathematical sequences. Establish common ground. Avoid revealing too much about our capabilities or vulnerabilities. Others argue for openness. Send encyclopedic transmissions containing humanity's art, science, history. Show them who we are in all our complexity. Still others argue for silence. We don't know their intentions. Responding might invite attention we're not prepared for. Caution is wisdom. The debates will take months, maybe years. But 3I. Atlas isn't waiting for our debates to conclude. On January 15, 2026, astronomers detect a new trajectory adjustment. Not large, just enough to refine the orbital period from 118 days to exactly 120 days. Perihelion to perihelion, a number that seems too clean to be coincidence. And the next perihelion is March 14, 2026, 0.98 AU from the Sun, just inside Earth's orbit, closer than Venus. As I write this in late December 2025, 3I Atlas is at 2.1 AU and moving inward, visible now as a magnitude +16 object in dark skies, requiring modest telescopes, but observable by thousands of amateur astronomers worldwide. It's still outgassing. The nickel tetracarbonyl signature persists. The uniform dust continues. Optically and spectroscopically, it behaves as it has since July. But we know what it is now. We know it maneuvered into permanent solar orbit. We know it transmitted deliberate radio signals at the most symbolically charged frequency in astronomy. We know it's positioned itself for long-term presence rather than brief flyby. We know we are being observed by intelligence that crossed the interstellar void to reach us. The deployed vehicles, if the October 18th detection was real, if there are indeed smaller probes we haven't tracked, might be positioned around Earth, Mars, Venus right now, observing continuously, measuring our response to the transmissions, assessing whether we're ready for direct contact or whether subtlety remains necessary. We don't know. Their intentions. We don't know if they're purely scientific observers, if they're advanced scouts for something larger, if they're missionaries from a civilization that reached the stars millennia ago and now guides younger species. We don't know if March perihelion brings further communication, physical approach, revelation of purpose, or simply continued enigmatic presence. All we know is that the question humanity has asked for thousands of years, are we alone, has been answered. We are not alone. We have never been alone. And right now, at this moment, something built by non-human intelligence is in our solar system, 2 astronomical units away, following an orbit that will bring it back to Earth-crossing distance in less than 90 days. The walls haven't just cracked, they've collapsed entirely. We're standing in the light now, exposed, visible, known to minds that think thoughts we cannot imagine, that solved problems we're still struggling with, that chose for reasons we don't understand to come here, to our sun, our neighborhood, our small corner of a vast galaxy. Why? That's the only question that matters now. And in 3 months, when 3i Atlas returns to perihelion, when it's close enough to observe with backyard telescopes, when it's positioned optimally for whatever next phase of protocol it follows, maybe we'll start learning the answer, or maybe we'll just receive more questions. Either way, the waiting is almost over. On March 14th, 2026, something will happen. Another transmission, a course change, a deployment event, a revelation, or perhaps just silence. Continued enigmatic presence, the object that changed everything, orbiting patiently, waiting for us to be ready for whatever comes next. I'll be watching. We'll all be watching. Because the universe just taught us the most profound lesson. We are not the only intelligence that looks at stars and wonders what lies beyond. Others wondered too, others built, others traveled. And now we share the same sky, the same solar system, the same moment in cosmic history when two civilizations, separated by light years and perhaps millennia of development, finally occupy the same space. What happens next isn't written yet, but it begins in March. And humanity will face that moment knowing with absolute certainty what previous generations could only dream about or fear. We are being watched, we have been found, and the silence of the cosmos has finally, irrevocably ended.